Okay, there we go. So, matrix A, matrix B. What are those? Big blocks with numbers in them. Like that. So we're going into this whole new area of math called matrices. You might have done some of it before. So how do you deal with big blocks of numbers like that? How do you subtract two matrices? Really, they just made up rules. I know that I'm always saying that, but that's really it, right? Remember, math is made up, and you really see that here. It's complete. They just said, "Hey, what if we put like numbers in boxes? We call them matrices, and we do stuff with them." Actually, that's really not the way it came about. They needed it for something in the real world. You can type it into Google. I forget. I thought it was for like mixing. I can't remember. I thought it was like beer production or something, and they had to mix things. I could be wrong. Type into Google, you'd find out like where do matrices come from. It's like the 1800s, 1700s. Anyway, maybe 1500s. I don't know. A while ago, and they were doing them. Anyway, so they made it. So they realized it would be helpful to have these boxes with lots of numbers in them for some real life thing they were trying to do. So they made up this whole new area of math. That's math. That's where it comes from. People are trying to do stuff. They realize they need math to help them. So they said, all right, let's make up these boxes with numbers in them. And then when you make up something new, you have to make the rules for how you add those things, subtract those things, multiply those things, divide those things. So let me ask you, if you were the one in charge of first making this up, how would you have made the rule for how you subtract two boxes of numbers? Would you say, hey, just add them all up, 0 and 1, 6, 7, minus 2 is 5, 1, that's a 6. Add these up, 6 and 6 is 12, minus 8, that's a 4, 6 and 4, it's 10. Probably not, huh? That would not be the way you would say, that's one way though, right? I'm just showing you there's not just one way to do this. And when we get to multiplying, you'll see they did something really strange. But for adding, subtracting, it's pretty normal. Well, you wouldn't do that, would you? You wouldn't say, that's how I'll add them. Just add all the numbers up and then add those two. No, that'd be weird, and that would not be useful. So what do you think they did for how you subtract two boxes of numbers? Cyrus?
Just a guess, but the answer seems to be in the same format as
yeah, good eye.
So with just each point of the square.
Exactly. Entry by entry, huh? Isn't that naturally what you'd all think to do? Totally. Just 0, just upper left with upper left. 0 minus 8. That's exactly what they did. Minus 8. Just go upper left with upper left. Not that other weird thing I did, right? Upper middle with upper middle. 3 minus 1, 2. Upper right with upper right. Minus 2 minus 0, minus 2. See what I'm doing there? Just entry by entry. 1 minus a minus 2. Careful.
3.
Positive 3, right? Because of the double negative thing. It's 1 minus. Remember, because there's a minus in the middle, because we are subtracting the matrix. That's in addition to the minus on the 2, huh? 1 minus negative 2 is 3. Goes right there. And then 3 minus 5 is negative 2. And 1 minus a negative 8?
9.
So that'd be 9, huh? 1 minus a negative 8 is 9. Goes right there. Oops. 9. There we go. Just as easy as that. Just entry by entry. That's the rule they made. They said, look, if you're subtracting them or adding them, just go entry by entry. Just like that. Okay? So we'll just get started on this section. We won't finish it. So 5. See what they have there? They have 5 times b. So they said, okay, we got to make up a rule for how you take one of these boxes of numbers called a matrix and you multiply by like a 5 or something. What do you think that means? Should you just multiply the first 2 by 5 or all of them, right? Obviously. Yeah. And that's not that they had to do it that way, but that is what they decided to do. They said just multiply them all. So all of them times 5. So that'd be what? 10, 5, 0, negative 10, 30, negative 20. I just did 5 times all of them. But you get it. All of them. We're done. Easy? Yeah, so far. Yeah, it gets weird when they multiply two matrices. Be totally fine on the test. These will be on the graphing calculator part if you want to learn how to do this. And I will do some of that tomorrow in class, show you how to put matrices in and do stuff. So if you want to just do them all on your graphing calculator, absolutely fine with me. That's what computers and calculators are made for, tedious things like this. So 5a minus 2b. How do you do it? Well, you know, just take matrix A, multiply all those by 5. So what's that? 5 times 0 is 0. 5 times 3 is 15. 5 times negative 2 is negative 10. And then 5, 5, 5. And then the other one, 2 times b. So multiply all of b by 2 times 2. The other one was times 5. And we get, what's that? 12, 2, 0, negative 8, 10, negative 2. And then we subtract them. Minus. So 5a minus 2b. Upper left, 0 minus 12, negative 12. Good. Am I going too fast? And then 15 minus 2. So 13, negative 10 minus 0. And then 5 minus a negative 8. What's that? 13? Because it adds, right? 5 minus 10 is negative 5. 5 minus negative 2 is 7. There we go. Is that good? Pretty straight ahead? Very natural, right? So, okay. Yeah, b times, right? There's no symbol between that b and c, so that means multiply. So, all right. How do we multiply two matrices? They want me to take matrix B and matrix C, and they want me to multiply them. That's weird. They're not even like the same size matrices. So now we get into the issue of how do you multiply two matrices like that are different sizes? How's that work? And look at the answer matrix. It's only got four answers, 4 boxes for the answers. How'd that happen? Anybody know? Anybody done this before? Nobody?
I don't remember how to do it.
It's been too fuzzy in the background, huh? Yeah, all right. So here's what we do. First off, let's talk about the size. Let's talk about sizes of matrices. Whenever you do the size of a matrix, this will be important. You go down first by across. I don't know why, because that's different. Because we're used to like a graphic, it's always across first, then the up down, huh? But for whatever reason, for matrices, they decided to go down first. Maybe it's because they start up here. I don't know. Whatever. They could have still gone across first. Whatever. Just so it knows, this is a 2 by 3, not a 3 by 2. Right? Because it's 2 rows down, 3 columns across. You with me? So I'm giving you the size. That's not the answer yet. I'm just saying the B is a 2 by 3 matrix. A is also a 2 by 3. It's 2 down, 3 across. C is a what by what matrix? 3 by 2. So everybody see what I'm doing? I'm saying how far down, how far across? Right? So I'm giving the size of the matrices right now. That's important because that tells us about the way they made up the multiplying. Here's what they did for multiplying. So for multiplying two matrices, you take, say you got an A, B, and a C, D. Let's say A by B and a C by D matrix. These inside numbers must be equal or you cannot multiply. Does that make sense? The two inside numbers, we got an A by B matrix and a C by D. The two inside numbers must be equal or you just cannot multiply those matrices. It's just a no-go. And if they are, you can do it. And what's the size, just the size, of the answer matrix? Size of the answer matrix is the two leftover numbers, A by D. So the size of the answer matrix will be an A by D matrix. So what does that mean? Well, let's look. We're trying to multiply this guy and this guy, the B and the C. So do the two inside numbers, this one with this one, do the two inside numbers, are they equal? Yes, they are. 3 equals 3. So that's a green light. You can drive. You can do this matrix. You can multiply it. They are equal. So that's a green light, go. You can multiply those matrices. And what will be the size of the answer matrix? The other numbers, 2 by 2. That's why they have a 2 by 2 setup.
So we only take the numbers that are on the left, the 2, and then the right?
No, I'll show you. We have a whole thing to do with that. But I'm just setting up the size right now. So everybody see how you determine the size of the answer matrix. The inside numbers must match, and when they do, green light, go, and it's the outside two numbers that tell you the size. So then you go, okay, so I'm looking for a 2, I'm going to make big blanks here, 2 by 2 answer matrix, 2 down by 2 across. So, okay, now how do you find those particular answers? Well, it's a weird, old, strange thing they decided to do. They decided to make, you're going to use all these numbers to do it. The first row you go across, and on this matrix you're always going down. Always going across there, always going down on the other one. So in other words, and then you multiply entry by entry. We're doing B. Are we doing B times C? Yeah, B times C. All right, so here we go. I know I've only got a minute left. Let me just do this once and we'll stop. 3 times 5. So you multiply and move. 3 times 5 plus, and then you jump. 1 times 5, and then you jump. 0 times negative 3. That's all the first entry. That's 1 out of 4 entries. And then you go over here, and you go 3 times 1. And you go 1 times 2. And you go 0 times 1. You add those up. Then you go down here. And you go here times here. And on you go. We're out of time. So we'll do more of that next time. Bring your calculators with you.